at least 100 students at a certain high school study Japanese. If 4% of the students at the school who study French also study Japanese, do more students at the school study French than Japanese? So sounds like an overlapping set where at our high school, all of our students, they either do study Japanese or they don't study Japanese, or they can study French or they don't study French. And then what would he know from our prompt? At least 100 students at a certain high school study Japanese. So our total Japanese would be this box here, and we know this is greater than or equal to 100. 4% of the students who study French also study Japanese. So that's 4% of my French students. So if I say my total students who study French is F, then the ones who also study Japanese, so that's the same as students who study French and Japanese, is 0.04F, which means 96% of my students who study French don't study Japanese. Do more students at the school study French than Japanese? So if I call this F and I call this guy here J, is F greater than J? Let's look at our statements. And so I'm going to circle everything I added to my table because it comes from the prompt. So I know I don't have to erase it. Statement 1, 16 students at the school study both French and Japanese. So that means this 0.04F here is equal to 16. So now I gotta be careful because this 16 comes from statement 1, but the 0.04F comes from the prompt. So what is 4%? That is 4 over 100, which is 1 over 25. So we can find our total French students as well. Should be 25 times 16, which is 400. So if I got 400 total students studying French, and 16 of those students study both French and Japanese, 384 of those students study French, but not Japanese. Now, can I answer my question? So I know a lot about my French students, but I don't know that much about my Japanese students, other than they are greater than or equal to 100. And so, therefore, I cannot really compare them to my 400 French students, because I could have 500 students studying Japanese, or I can have 200. So our first statement is insufficient. Statement 2 says, now I got to forget about this stuff here. 10% of the students at the school who study Japanese also study French. So they're saying, if I call my Japanese students J, then Japanese and French is going to be 0.1 J. Because this 0.04F came from my prompt, I know 0.04F is equal to 0.1 J. So 4% of my French students is equal to 10% of my Japanese students. So do I have more students at my school studying French or Japanese? Well, let's get one in terms of the other. So I can multiply each side of my equation here by 100. to get, this means 4F is equal to 10J. And so my French students are equal to 10 over 4 times J. 10 over 4 is 2.5. So if my French students are 2.5 times my Japanese students, then I certainly have more students studying French than Japanese, and this statement is sufficient, and B is our answer. And I see this question is a bit tricky because I think the order in which they present the statements is they're trying to throw you off a bit, because in our first statement we were able to find discrete values based on the numbers they gave us, whereas in our second statement we were only able to find relative values. So it might seem like there's no way the second statement could be sufficient when the first one wasn't sufficient. However, we only need relative values because it's only asking about our French students relative to our Japanese students. And so we were able to find out that we have more French students without even finding out exactly how many students we had in either for either language. So B.